Hi, everyone. Today we are going to go over our double angle and our half angle formulas, and then we're going to tackle some concrete examples involving both double angle and half angle formulas. So let's jump into it. Our objectives, we only have two, right? Using double angle formulas, first objective, and then using half angle formulas, second objective, in order to find our exact values. So let's first look at our double angle formulas for our trig functions, sine and cosine. And uh, you guys, I highly recommend that you create index cards for these four double angle formulas. Um, I have implanted in my head at this point that there's only one sine double angle formula, and then all the rest are cosine. But yeah, highly recommend the flashcards. Uh, Down here, we just have a little comment saying that these formulas give us the opportunity to find values of sine and cosine at 2x from their values at x, aka double angles. And the formulas are immediate consequences of our sum formulas that we tackled in our past lesson. So let's jump into it and look at our example one. We have two different parts. And we also want to look at this bound that they give us. We have that our theta is between 90 and 180 degrees, our pi over 2 and pi. So if we look at it from a coordinate perspective, our first, our second, our third, and our fourth quadrant, all students take calculus. We are between 90, aka pi over 2, and pi 180. So we're in this second quadrant, which tells us that our sign is positive. Something to be mindful of as we apply our double angle formulas and are dealing with cosine too, because then cosine will jump into the negatives. So remember, there's one sine double angle formula, and our sine double angle formula is 2 sine theta cosine theta. So we have for part A, our sine of 2 theta is equal to 2 sine theta cosine theta. And we're given sine theta. That's just 3 over 5. Well, then what about cosine theta? Just again, think back to our famous right triangle. We have a Pythagorean triple here, right? If sine is 3 over 5, then cosine is 4 over 5, but our cosine is negative in our second quadrant, so it's really negative 4 over 5. Okay. So now we're going to plug in these guys. Maybe I'll put this above for here so we can use it for both A and B. I'll bring this down here. And so when we plug in, we end up with 2 in parentheses, 3/5. I'll do some color coding so you guys could really see it. Close parentheses, in parentheses, negative 4/5. So we'll make this yellow. And then this one blue. Now let's just multiply straight across. And we get 2 times 3 times -4. That gives you -24 in the numerator, all over 5 times 5, which is 25 in the denominator. And so that gives us our sine of 2 theta. And we're done. Now let's take a look at cosine of 2 theta. And cosine of 2 theta, we have 3 different options. We have our cosine squared theta minus our sine squared theta. We have our 1 minus 2 sine squared theta. And then we have our 2 cosine squared theta minus 1. And so since we have both sine theta and cosine theta, we can really use any of them. I will say, let's just use the first one, our cosine squared theta minus our sine squared theta. So cosine 2 theta equals cosine squared theta minus sine squared theta. And I think what I'll do is, why don't I put all of our double angle formulas that we have on this page on here as well. Here, I'll save time by pausing. All right, so we shrunk this and moved this over to the side or included it so you can start getting familiar with these formulas. Okay, and now let's do some plugging in. Our cosine theta is -4, but now we're squaring it. -4 over 5 in parentheses squared. Our sine is 3 over 5, but we're squaring that. And so we get 16 over 25. Let's zoom in over here. Minus 9 over 25. And so 16 minus 9 gives you 7. So our final answer for our cosine of 2 theta is simply 7 over 25. And we are done. Okay. So let us continue. Let's look at example 2 now. And so example 2, we have cosine x is equal to -2/3. And then we're given x is in quadrant 2. So again, only sine-related functions are positive here. I'll highlight this so you can really see it. And we want to find cosine of 2x and sine of 2x. So our sine of 2x, again, is the same as 2 sine of x cosine of x. And then our cosine of 2x, we have 3 different options. Our last example, we did cosine squared x minus sine squared x. Why don't we use that second condition now, which we have to be as 1 minus sine squared x. And then maybe in this future example, we'll do the third one, our 2 cosine squared minus 1. So we have our cosine 2 theta is equal to our 1 minus 2 sine squared theta. And let's put this in terms of x. Okay. And let's carry them out. So we're going to call this A, and we're going to call this B. And we're given our cosine of x. Let's utilize our right triangle properties again. This is our angle x. Cosine is adjacent over hypotenuse. So we end up getting -2 squared plus b squared equals 3 squared, or b is the square root of 9 minus 4, which is just square root of 5. And then that will tell us that our sine of x is square root of 5 over 3. Okay, so now we can really utilize subbing in. We have everything. Sine of x, sub in square root of 5 over 3. And then we just have to be mindful that it's being squared in that second one. And then our cosine of x is -2 over 3. So let's plug in, and I'll pause to save time. All right, we substituted in properly, and now we are going to just simplify. So we have a -4 square root of 5 over 9 for our double angle sine. And then for our double angle cosine, we have 1 minus square root of 5 squared is just 5. So 2 times 5 over 9. 1 as a fraction is just 9 over 9. So we have 9 minus 10 over 9, which gives us -1 over 9 for cosine of 2x. And we are done. Let's keep going. And so now we're on to our second objective, which is learning about our half angle formulas. Again, some more flashcards to create. And again, these are really derived from our sum and difference formulas. It's just you can get to your values in a quicker manner by using these. If you forget these on the exam, then again, just go back to your knowledge of sum and difference. And so this comment on the bottom is stating that they relate the values of sine and cosine at 1/2 x to their values of x, aka half angle formulas. And then these plus and minus signs just determine what quadrant we're talking about. So if it's positive, then this alpha over 2 is telling us, well, the angle itself, right? If it's 60 degrees and we're referring to sine and we're in the second quadrant, then we have a positive value, even if we're in the first quadrant. But in the third and fourth quadrant, our sine is negative. So then it would be negative. Okay. So now we're going to practice our half angle formulas. We have both the cosine and the sine. they're the same formulas. The only difference is underneath the square root, that numerator, you have either 1 minus cosine alpha or 1 plus cosine alpha. If it's 1 minus, then we're dealing with the half angle of sine. If it's 1 plus, then we're in favor of the cosine, so we're dealing with our half angle of cosine. So that part A, we're dealing with cosine. And so I'll just write out the general formula. Cosine of our alpha over 2 is equal to our plus or minus square root of 1 plus our cosine theta all over 2. Okay. And now, what is our alpha over 2 here? It's just 15. So if alpha over 2 is equal to 15, then what is alpha? Alpha is just 30, right? Okay. And now we're going to plug in. Why do I have a theta here? This should be alpha. And so now we just have our solution to be 15 degrees. That's in the first quadrant. So everything's positive. So we're looking at our positive value of the square root of 1 plus cosine of 30 all over 2. Cosine of 30 is what? That is square root of 3 over 2. And it's all over 2. And then we can simplify this a little bit more, right? Because that looks a little ugly. 1 is the same as 2 over 2, so we have 2 plus square root of 3 over 2, all divided by 2 as a fraction is 2 over 1. So when we keep change flip, we get 2 plus square root of 3 over 4. And we can take the square root of the denominator, so we're left with 2 plus square root of 3 all over square root of 4, which is just 2. So that is our cosine of alpha over 2. Let me shrink this so that we have more space to solve our part B. So, much better. Now let's move on to B. Sine of negative 15 degrees. What do we know about sine? Sine is an odd function, so we can take out that negative. And now we're looking at sine of positive 15 degrees. Now, because we're dealing with sine, and we know sine of 30, let's use our half angle formula. And now we have the square root of 1 minus cosine alpha over 2. And again, it's the first quadrant, so we have positive square root 1 minus cosine alpha over 2. And what's our alpha here? Well, again, if alpha over 2 is 15, this implies that alpha is just 30 degrees. So maybe I'll put this off to up here. And now we end up with, we have this negative. So ends up being a negative square root because we have that negative in the problem itself. And then 1 minus cosine 30 all over 2. Cosine of 30 gives you, once again, square root of 3 over 2. It's just now you're not adding, you are subtracting. So get those common denominators. 2 minus square root of 3 over 2. All divided by 2 as a fraction is 2 over 1. Keep, change, flip, and you get over 4. Which means you can take the square root of 4, so your final result is 2 minus square root of 3 underneath a square root all over 4. And I'll maybe just put that in as our final answer. And there we have it. This, I forgot to take the square root over there. That's 2. But I wrote it correctly down here. And we're done. Let's do another example together. So we're doing half angles for both cases. Again, sine of alpha over 2 is 1 minus our cosine alpha all over 2, and then the square root of all of that. But now we have to figure out we're given cosine alpha, which is negative 3 over 5. Negative 3, 5, and then alpha. So Pythagorean theorem will make this 4. And they give us the angle is between pi and 3 pi over 2. So we're in the third quadrant. Which means sine and cosine are negative. So we have a negative 4 there. And by SOHCAHTOA, we have our sine of alpha is negative 4 over 5. Okay. And we want to find sine of alpha over 2. So we have our cosine. Let's just plug it in. Technically, we didn't even need to find our sine of alpha. And so we plug in negative 3 over 5 here. One minus negative 3/5 all over 2. 1 as a fraction with denominator of 5 is 5 over 5. So then we get 5 plus 3 all over 5. 2 as a fraction is 2 over 1. So we get 8 over 5 divided by 2 over 1. And if we keep, change, flip this, we get 8 over 10. Which is reduced to the square root of 4 over 5, which is just 2 over square root of 5. And then we should really rationalize the denominator. So let me shrink this a bit. Multiply by our square root of 5 over square root of 5. And so our final outcome is 2 square root of 5 over 5. Again, our theta is in that third quadrant. And so theta over 2 half of the angle should be negative. We want to look at it over at theta over 2. So what we'll do is in the bounds, we divide this by 2, which will make this 3 pi. Our new bounds are going to be pi over 2 is less than alpha over 2, which is less than 3 pi over 4. And pi over 2 is 90 plus 45 is 135. So between 90 and 135, that's the second quadrant, so it's going to stay positive. So our final sine of theta over 2 is positive 2 square root of 5 over 5. And we're done. Now let's look at our B. And now that we did the whole alpha over 2 here to get between 90 and 135, we know that that's in our second quadrant where sine is positive, but our cosine is negative. Okay. So we have our cosine of alpha over 2 is equal to our square root of 1 plus cosine of alpha over 2. So our cosine of alpha over 2 is a negative value. And we have the square root of, essentially, we don't have to do all of this calculation and work again. We just have to, instead of adding, right, because those two negatives, we're going to be subtracting 1 minus 3 over 5 over 2. So 1 minus 3 over 5 over 2, which is the same as 5 minus 3 over 5. And 5 minus 3 over 5 over 2 over 1 is just 2 over 5 over 2, which is 2 over 10. And so that square root of 10 can be simplified. Open it. No, but we can simplify the fraction to 1 over 5. And we know the square root of 1 is just 1. So we have negative 1 over square root of 5. Rationalize the denominator, and we end up with negative square root of 5 over 5. Let me shrink this and make it a little neater for you guys. Much better. And we are done. Now let's move on to our last example for this section, where we're asked to find the exact value of sine of 22.5 degrees. And so again, we have our sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine theta all over 2. Keep saying theta, and we're talking about, it doesn't matter as long as these two variables are the same. Okay. So we're going to let our alpha over 2 be equal to 22.5 degrees, which tells us that our alpha is 45, an angle that we are quite familiar with. And so another thing to keep in mind, 22.5, this puts us into our quadrant 1, which means everything positive. So we're good. So we are looking at the positive square root, like, compares to our sine alpha over 2. And then we want to figure out cosine of alpha, so cosine of 45. Cosine of 45 is just square root of 2 over 2, based off of our table. Let us simplify this fraction. 1 as a fraction with a denominator of 2 is 2 over 2. So this is the same as 2 minus square root of 2 all over 2 divided by 2 as a fraction is just 2 over 1. So when we keep change flip, we have the square root of 2 minus square root of 2 all over 4. And we can take the square root of 4. So our final answer is the square root of 2 minus the square root of 2 all over 2. I'll shrink this so it's a little more organized. And there we have it, our final answer. So I hope that this was helpful. That completes our section 9.3 of our double angle and half angle formulas, which is almost the end of chapter 9. We have one more section, which we'll cover next, and that is solving our trigonometric equations. All right, see you all next time. Take care.